The first time during my medical training that I laid my eyes on a bone marrow smear, I was hooked.
She is boundless in her energy.
She's a superb clinician, a world-class researcher.
She's very tough and very focused and very dedicated and just incredibly curious.
When I think of her as a scientist, I think about her rigor, that she is can take a complex problem and take it apart and look at its pieces and then reconstruct it in ways that make sense and ask the critical questions.
She was able to make significant contributions to different aspects of this field that normally would be one person doing one area and another person doing another, but not the same person working on different aspects of this field.
She was able to understand a way to identify the production of fetal hemoglobin, which was an incredibly powerful tool to understand globin switching.
Thalia and her husband George were among the very first to show that if you could modulate the rate at which a progenitor cell makes a red blood cell, you could kind of fake it out and cause it to make fetal hemoglobin, if you could accelerate the rate of differentiation. She's an exceptional morphologist. Under the microscope, there's nobody that comes close to Thalia. And looking at the cells, making it feel like you're on this voyage as you go through the slide, nobody does that better than Thalia.
Thalia is quite versatile in her academic interests, and she really brought rigor to the field of stem cell transplantation.
And she found that by producing and generating an antibody to one of the hidden molecules, she was able to interrupt that connection. And she found that actually stem cells now moved out into the circulating blood in an accelerated manner.
This was the first time a mechanistic clue was uncovered, indicating that this pathway that we're looking at was important for retention of stem and progenitor cells in bone marrow.
These are phenomenally interesting biological processes that have huge implications in the setting, for example, of stem cell transplantation. And Thalia has been absolutely one of the world's leaders in understanding the precise molecular mechanisms by which that occurs.
Well, Thalia has been a mentor to literally dozens of fellows who've come into or scientists who've come into our laboratory from all over the world.
Her mentees need to have scientific rigor. They need to be scientifically creative and think outside the box. They need to be independent.
So she's just happy to help at any stage, in any way. She's the mentor that someone seeks out.
She's been very active in ASH. She's had multiple responsibilities over the years. She's served on panels and study sections at the National Institutes of Health.
She was always fighting for the young people, seeing the complete picture, very articulate.
I have followed ASH meetings religiously, and over the years, I have served in several committees, and all I have to say is that I got a lot more out of it than I could ever deliver.
The Wallace H. Coulter Award for Lifetime Achievement in Hematology recognizes Dr. Papayannopoulou's many contributions to hematology.
One of the things about Mr. Coulter was how creative he was with science, that he saw a need in the Coulter counter and describing blood cells, and he figured out a novel way to do it.
He was a guy with a vision, and I think in some ways this applies to Thalia as well.
Mr. Coulter, with his engineering discoveries, had a gigantic transformative effect in the practice of hematology around the globe. I deeply share Mr. Coulter's lifelong devotion to hematology, and I accept the award in his name with great humility and eternal gratitude.